Hey guys, it's Aaron and Bryce, and we're here once again because guess what? There's another huge update coming to Fusion.
Yeah, Aaron. This one has enhancements across all the different workspaces.
Well, we have a ton to show you, so let's just jump right into it. Modeling in Fusion 360 just got a lot easier. Here you can see I have a ball valve, and on either end there are two different flanges, a threaded version and a weld neck flange. These flanges are missing the hole pattern needed to accommodate the bolts. So let's see what we can do now, which will uncomplicate features of this type. After using a selection filter to get the sketch profiles, I'll begin defining the properties in the extrude dialog. To avoid having to do this feature twice, I'll have this go in two directions and through all. As it starts the preview, you can see there are a couple of unintended cuts, through the valve housing, the cap, and many you can't even see. To avoid these cuts in the past, I would either need to do this in two separate features or hide everything I wanted to avoid cutting. But now, thanks to the Objects to Cut toggles, I can avoid cutting any of the parts I want to leave untouched. You'll find objects to cut in revolves, sweeps, and lofts, so avoid tedious hide show steps and make those features more efficient. But even those so-called tedious hide show steps just got a lot easier thanks to some amazing new selection tools. Select by name is especially handy in this case because all my McMaster hardware starts with 9. Select by boundary allows me to make a handful of boundary shapes, and I can select inside, outside, or even intersecting models. I've already used Select by Size to remove hardware and small bits from an insanely over-detailed design by our very own Jay Tedeschi. There are also selection priorities, which can be set to bodies, faces, edges, or components. I'll use components here to get just the housing and the cap, then use the final selection tool, Invert, to select everything but those two items. Hitting V will hide everything but the housing and cap, making the next design changes simple. A great tool to have. But let's pass over to Bryce now to see what's new in the CAM workspace.
In this Fusion 360 update, we have a lot of big enhancements to the CAM workspace inside Fusion 360. To start off, we have added different samples of work holding that can help you with your CAM setups. We have added examples from 5th Axis, Raptor, Chick, and more. We will be adding even more work holding samples to this folder as they come available, so keep checking back in. Now start placing your parts in the vise you are using in your machine to make sure there are no collisions with the way you are fixturing your part. Next, we've added 3 new tool types to the CAM tool library. In this update, we can now create and customize tapered ball end mills, face mills with a corner radius, and thread mills. Now our next CAM enhancement brings probing to Fusion 360. Probing can be used to set your 0 points on your part and also can be used to find coordinates on your part. First, we will select our probe from the tool library. Probing is something you do at your machine. Next, let's select the probing surfaces. Then Fusion 360 will determine our probing type depending on our selection. You will also need to make sure probing has been added to your post-processor. Now, depending on the selection, you will get different probe types to locate different points. In this last example, we will choose to have the probe type of an XY circular hole with an island in order to avoid this center extrusion. Let's change the clearance to ensure we don't collide with this circular boss. I can set the clearance to specify the distance that the probe will stay clear from the selected feature. This is the point it rapids to at a distance from that wall. The over travel is the distance the probe is allowed to move to search for a contact. We don't want to damage the probe, so if the probe travels the specified distance without finding the wall, it will stop. Now let's talk about some of the new 4-axis simultaneous toolpaths that are in this Fusion 360 update. This toolpath will be essential for machines with a rotary axis. We now have a wrap option in the 2D adaptive clearing, 2D pocket, and 2D contour toolpath in order to wrap around cylindrical objects. The wrap toolpath is a new option on the geometry tab of these toolpaths. Once enabled, let's select the outside diameter. Notice the radius is automatically populated. Now, just as with any other 2D adaptive toolpath, we can select the edge to determine the distance that will be roughed out. Now, once Fusion 360 starts calculating, behind the scenes it will unwrap the selected boundary, then apply the toolpath, then rewrap the toolpath correctly on the cylinder. In this example, we have several instances of this pocket. Rather than programming each pocket manually, let's use a circular pattern to ensure this roughing strategy cuts all 5 pockets. Now let's move on to some of the new 5-axis simultaneous machining strategies. Our first strategy will be the new tilting option in the 3D contour toolpath. The tilting option will allow me to use a shorter, more rigid tool and get deeper in the pocket without colliding with the part. Notice that the tool I selected has a holder. Since I definitely don't want that to collide with the part, I will also turn on shaft and holder detection. Tilting will now take the holder into account when moving deeper into the pocket. Now let's move on to the Passes tab and select multi-axis tilting. When this option is checked, the tool will start to tilt when required to avoid a collision. We can input values like maximum tilt and maximum segment length to control the tilting. Now the tilting option adds more time to the toolpath calculation. Luckily, Fusion 360 CAM is multi-threaded, so we can continue working on other toolpaths while this is being calculated. Notice in the simulation, we can see the tool start to tilt when the holder is about to collide with the part. Next, let's move on to the swarf strategy, which is another 5-axis toolpath. Swarf is a side-cutting toolpath. This will use the side of the end mill to cut the selected surface. This toolpath is great for beveled edges and tapered walls. Swarf cutting uses the whole cutting length of the tool, resulting in a better surface quality and shorter machining time. To machine these surfaces with a 3-axis strategy, this would require multiple passes with a ball end mill, which would increase the machine time significantly. Now, our last 5-axis machining strategy for this update is the new multi-axis contour. This contour will tilt the tool along a chain 3D profile drive curve, making it ideal for generating 5-axis toolpaths for deburring, trimming, and engraving on a 3D surface. Initially, the tool will move normal to the surface, but lead, lag, and sideways tilt can be specified to engage different portions of the tool.
Man, we're bringing probing 4 and 5-axis toolpaths to Fusion 360. That's going to open us up to even more machines we can program. But I hear you've got something to show us here, Aaron.
Yeah, I'm going to be showing simulation, and one thing I need to note from the get-go is that we've standardized on the NAS solver, very powerful stuff, and we've effectively doubled the number of simulation types that you have access to. So let's take a look at some of this power. Okay, there are a ton of new things I need to talk about in regards to simulation functionality. To kick it off, I'll use this GE jet engine bracket model that was part of an online design challenge. In that challenge, they described multiple loading conditions, and they also described the constraints to be in the form of bolts. Previously a limitation, now Fusion 360 allows me to use bolt connectors to more accurately constrain this model. These bolts can be defined to be connected via thread or to a nut, and can account for things like washers. And don't forget the oh so important preload. In this case, I'll define this from a Fastenal reference, a great resource for information of this type. From there, this is ready to solve, as all the load cases reference those 4 connectors, and in a short time, I'll have results to use to drive the next design iteration. Due to the multiple load cases, I can choose to view each by using the dropdown, but what would really help is to see the different results at once. Good thing there's a new compare workspace, which allows me to do just that. I can compare up to 4 different results by using different layouts, and what's showing in each window is customizable. Whether you show different results from the same load or show one result across different load cases, it's up to you. Comparing is made easier with the ability to synchronize the camera views, results, and even scaling. This compare tool brings an exciting addition to Fusion 360. Speaking of synchronizing, did I mention all of Fusion simulation is now using the NAS solver? By doing so, this adds tools, such as the bolts you just saw, but it also adds a plethora of new study types. Here you can see a buckling study. This water tower has a couple of different buckling mode shapes, but the most important to me is the first, which by being less than 1 indicates this model will buckle under the intended load. To understand how it might buckle, an exaggerated animation always helps. Armed with that knowledge, let's make some design changes to help stabilize this. An additional brace and leg might do it, and after a quick rerun, the results come back, and that buckling load factor of greater than 1 is a welcome sign. If you have transient loads, you can use event simulation. And with the ability to delete elements, you can get some real groundbreaking results. Sorry for the lame pun, but another use case might be something like this buckle. As I animate through the steps, you can get an idea of how stress and displacement change as it goes from rest to close and back again. And information for each step is saved out and easily accessible. Similarly, let's look at solving a nonlinear problem that everyone finds annoying. Bent utility knife blades caused by misuse, such as when someone uses it as a flathead screwdriver. With just 2 components being analyzed from a larger assembly, it might seem contacts would be few and far between. But when I automatically create those, I get more than I bargained for. The new Contact Manager makes it easy to find and alter those. As I select them, they'll cross-highlight in the graphics area, and I can individually change these to the right contact type. To help get better results at the tip, let's make the mesh really fine. With the latest update, I no longer need to adjust the mesh globally to capture that detail. I can instead use a local mesh control found in the Manage dropdown. This allows me to specify faces, edges, or bodies to refine just the area I'm most interested in. With the results back again, I'll have the ability to view step by step what happens with this, which is important with nonlinear problems, as sometimes the nonlinearity is in the form of large displacements, changing context, or post-yield material behavior. To further interrogate this, the last thing I'll do is probe the stress along the face, which, please note, will be found under the Inspect dropdown. But back to the jet engine bracket, let's use a study I am so excited to use, especially in cases just like this. Instead of going through tens or hundreds of design iterations to optimize the shape to handle the load, why not just have the software do it for you using a shape optimization study? Using this shape optimization, I can set goals, such as reducing the weight to 20% of the original while maximizing stiffness. And I can even preserve regions to maintain areas that might need to connect to other parts. Like this cylindrical region, which is easy to manipulate with press-pull handles. But something to consider is that any faces with loads or constraints will automatically be preserved, which makes complete sense. If anything I've said doesn't make sense, make sure to check out the new Getting Started tutorials within the simulation workspace. These will allow you to learn all about how to, and more importantly, when to, use the different study types. But let's see this optimized shape. Luckily, I don't have to wait much longer, because the entire time I was showing you the shape optimization setup and Getting Started tutorials, another study was solving in the cloud. Gotta love that. Not new, but I have to say I use it all the time. Anyway, once it finishes, I can view the load path results to start to visualize the optimized shape. But let's go beyond visualizing it. Let's promote this to a mesh body. Now I can use the mesh workspace to drive the design, or take this and make it more machine friendly.
In this update, we have several key enhancements that will extend the capabilities of the drawings environment. First, to consolidate with the rest of Fusion 360, we have added a browser to the left side of the drawings environment. Here we can expand and see the assembly structure used in the design. Notice that there's only one assembly icon in the browser for the Hewland FTR. Now, when a new base view is created, it will ask for a reference. We have the option to tie this view to the existing assembly in the browser or create a new one. In this case, we will tie it down to the existing assembly design. Now notice when I suppress components from the browser, the component is suppressed from all the views. Now let's create another new base view. In this case, for the reference, we will choose to create new. Once the view is placed, you will notice that we have a second instance of the Hewland FTR design in the browser. This can be independently controlled from the previous three views. Note that for projected, section, and detail views, they will automatically inherit the parent view's assembly design in the browser. Now let's create a parts list of the isometric view. Note a parts list can be created for both assembly items in the browser, and they can both be controlled independently from each other. Now, I want this outside gear final drive to not be in the view, but still appear in the parts list. In this case, I could hit the light bulb next to the component to make it hidden in the view, but still in the parts list. Notice when I hit the checkbox now, it will change the parts list and remove that component. The checkbox suppresses where the light bulb hides and shows. Another way to create complex views in drawings is by using named views. Previously, we were able to use named views in drawings, but now in this update, we can tie dimensions, center marks, and center lines to named views. This is an excellent workflow to create auxiliary views. Now, this next enhancement is one of my favorite nuggets in this update. We can now export the parts list in a CSV file to use in other processes of the company. Finally, if you like to use inches for drawings, this one is going to be a game changer. Now we can choose for the units of a drawing to be displayed in fractions. Notice that some of the decimals were rounded to the nearest quarter. This is controlled from the bottom in the dimension precision.
Hey guys, thanks for watching this one all the way through. We know it was a long one, but we had a lot to show you.
A lot of powerful new tools coming to Fusion 360. Make sure to check out the quick tips in the Learn page. We're building those out as fast as we can to help you learn this new functionality. And keep your eyes peeled. As you know, there's always tons more coming to Fusion 360.
Just wait till what we got next.
Cheers.